So imagine this scenario, and it involves momentum and collisions and elastic versus inelastic collisions, really. You are in your dorm room or wherever room you can be right now, and your door is open, and you want to close it, and your bed is aligned such that if you threw something at the door, it would close it. Next to your bed, and you're tired, you don't want to get up, you have a super ball, and you have a piece of clay, and they both have the same mass. Which one would be more likely to close the door if you threw it at the door? Would it be the clay, or would it be the super ball? Think about that, and I'm going to show you a demonstration now that will hopefully convince you of the answer. .9 grams of clay. All right, 3.0 grams of clay. .8 gram super ball. So this clay is actually slightly more massive than the super ball, but they're really close. So Dan, what I'm going to do now is I'm going to release the super ball on this side, the clay ball on this side, from a certain height here. Both balls are going to hit this piece of wood here, or that piece of wood there, and we're going to see which one knocks over. Release them from the same height. Now maybe you say, hey, that piece of wood's lighter than the other piece of wood. They're the same, but I'm going to swap them just so that I'm not favoring one piece of wood over the other piece of wood, or one ball over the other ball. But it was the super ball that knocked it down. Let's see again. The super ball's the one on this side here. So let's see if the same thing happens again. I'll release them both from the same height, which means they'll have the same final velocity. It's conservation of energy. Same result. The super ball was more likely to knock over the piece of wood in either case. So now you're probably wondering, why did the super ball knock the wooden block down? Most students think it's going to be the clay ball. Most people think it's going to be the clay ball, unless they think about conservation of momentum. And so here's where we can really apply this idea. Since the super ball and the clay ball both have the same amount of mass, and since I'm raising them to the same height, when they hit the wooden block, they're both going to have the same final velocity. Keep that in mind. If they have the same mass and the same final velocity, they're going to have the same momentum in both cases. I'm going to call that momentum what I have here in column B, the initial momentum, P initial. And both the super ball and the clay ball have that same initial momentum. After the super ball bounces, or hits the wooden block, here's the wooden block, it's going to bounce away from it. In the ideal world, the super ball, therefore, if it's coming at the clay block with a momentum of P initial, it's going to bounce away with a momentum of minus P initial. Truth is, it's not going to be a perfectly elastic collision, but more so than the clay ball will be, because the super balls are designed to bounce. So it's going to bounce away. I'm going to say it's minus P initial so that it changes direction. So the momentum had been this way initially. For the super ball, it's now that way. So I'm going to define its momentum, state that its final momentum is going to have a value about negative of the initial value. The clay ball, on the other hand, when it hits the wooden block, it's basically going to stop moving. It's not going to bounce away, or it's going to bounce much less than the super ball will. So I'm going to give it a final momentum of 0. These are kind of both extreme cases, but they illustrate the point. And what we see then is that the super ball changes its momentum more than the clay ball does, because it bounces away from the wooden object here. So therefore, the change in momentum of the super ball is going to be twice that of the clay ball. Well, where does that extra momentum go? There's only one place it can go to, and that is to the piece of wood. So if the super ball changes by negative 2 P initial, the wood block gets 2 times P initial. So the wood block gets twice the momentum in the case of the super ball than it does in the case of the clay ball. In other words, it receives a greater impulse, and that causes the wood block to fall over.